hypothetically,
this
is
is that
cover up this with a label. But you and I are clever. We do not need to have these labels. We look at this model and we know it's not a brain, because a brain has gray cortex superficial with the white matter that tends to be more deep. But here we have some gray matter that's in the center with white matter that's superficial. This is a spinal cord.
Haven't a lot of people told you brain before?
I have seen it, but I've seen everything.
Yeah.
Okay. Now, what we look for here is there's a pointed area. Now, pointed points to the posterior. It's almost like someone's giving you a reference. Where's the back? It's back that way. Posterior, that's the... What horn would be pointed here to the back?
Posterior.
Posterior horn or the dorsal horn. Either is acceptable on the exam. Now, what happens is this going to receive information from a sensory neuron or from a motor neuron? Sensory. And the sensory, I love that word always, will always enter into the spinal cord through the dorsal root. What's this enlargement that looks like a little gerbil inside a snake?
Root ganglion.
The dorsal root ganglion. We have one here on the side. We have a number over here. I can't see it without my glasses.
24.
So the green and the yellow must be sensory because they're coming into the dorsal horn regions. So this must be sensory, or as your book says here, this must be afferent. We know sensory and afferent are synonymous 100%. In lecture, they might tell you there's a difference between somatic that goes to skin, muscles, and joints, different from internal organs like smooth muscle, cardiac muscle, endocrine glands, exocrine glands. But nonetheless, all sensory enter through the dorsal root, through the back door. They form a synapse with the gray matter. Not shown are interneurons. They tend to be shown in our model, in our book, as green. Then information will either ascend, descend, or stay within the spinal cord as what we call a spinal cord reflex. The reflex will send action potentials out the front door. What is this root? The ventral root. Can anybody find the ventral root ganglion?
Non-exist.
If you can, we need to give you a Nobel Prize or something. You're seeing things. So here we have a ventral root, and it is always, I love that word, motor function. What's another name for motor? Efferent or efferent, whatever you want to pronounce it. Now we can also have things, somatic means goes only to skeletal muscles. When we say somatic afferent, it's from skeletal muscles or joints or from the skin. But when we say somatic motor or somatic efferent, it's going to only skeletal muscles that were both voluntary and striated. That was chapter 4, or histology. So the information, action potentials leave through the ventral root, and then the dorsal root and the ventral root will merge. What do we call that mergence?
A nerve.
That's a nerve. And a nerve that emerges from the spine is called spinal nerve. Oh, I love it when it makes sense. And then eventually, we're going to have this structure here is going to become a ventral ramus. And the word for ramus means branch. So there'll be a branch that comes in the front. What is this smaller branch called? The dorsal ramus. We don't emphasize in lab these two, but they're called the rami communicans. They're used mostly for the sympathetic autonomic nervous system. They're going to eventually connect to a thing called the sympathetic chain ganglion. But we're getting ahead of ourselves because that's chapter 14. What do we call this horn back here in the backside?
The dorsal horn.
What do we call the horn in the front?
Ventral.
What do we call the horn on the side?
Lateral.
What do we call the white matter? And this is very fun. Funiculi. This is a dorsal funiculus, one column. What do we call the white structure on the lateral compartment?
Lateral.
Lateral funiculi. What about here in the front? Ventral funiculi. What do we call those white matters that have many funiculi that are bundled together? Starts with a C.
Columns.
Columns. And the columns will either ascend up to the brain or descend from the brain. We have ascending tracts and descending tracts mostly through the columns. What cell made these columns white?
Oh, pogliodentrocytes.
That's exactly right. This is central nervous tissue, so don't say Schwann cell, say common mistake. Get those right. Schwann cell is to
Central.
PNS,
Okay.
as oligodendrocyte is to,
CNS.
did I say it back
Yeah,
up?
you said it.
CNS. Did I say it right?
Yep.
Sometimes I can't think and do everything right.
Yeah.
All right. Is there a structure here you want to go over? You want to go over this model?